Hi, everybody. Happy Friday. So, if you fill out your schedule, please give it to me so I can make an appointment with you in the future. And our schedule is right here. So, today we're going to talk about session 7.1. And next week, we're going to talk about session 7.2. So this week, I print out worksheets for you. But starting from next week, we're going to print out the worksheets. Okay? Do you all know how to print out the worksheet from the library? Yes? Okay. Go to the first floor. It's black and white. And the second floor is color. So color is more expensive than the black and white. Yes. Okay, so let me see. Okay, it's recording. All right. Let's get to the 7.1. Yes, so today we're going to talk about 7.1, antiderivatives. So if you talk apply Cal 1, we talk about antiderivatives and the U substitution already. So you can imagine this class is kind of review of like what you learned in the last week of the apply Cal 1. So last time I gave you the formula sheet. Remember this formula sheet? We have derivatives and the antiderivatives, right? Make sure you can memorize these. So again, derivative of x to the n is n, you bring the power down in front, times x to the n minus 1. So when you differentiate, the power drops down by 1. Right, everybody? So when you integrate, integration is like the reverse process of differentiation. So when you integrate, your power increased by 1, and then you divide it by the new exponents. Right, everybody? And because antiderivative represents like the area under a curve, and when you shoot the curve up or down, the derivative at all the points still be the same, right? So that's why all the antiderivative they could differ by a constant c. So that's why we have the plus c for integral or antiderivatives. Okay. And when we differentiate exponential function e to the ax, because of chain rule, right? It's e to the ax times the ax prime. The ax prime is actually a, right? Do you remember chain rule? Yeah. So that's why when we differentiate, we multiply by a, and when we integrate, we divide it by a. Okay, and then b to the x. When we take the derivative of b to the x, we multiply by ln of b. Okay? And when we integrate, we divide it by ln of b. Okay, and the derivative of natural log of absolute value of x is 1 over x. So integral of 1 over x is natural log of absolute value of x plus c. Are you all okay with that formula? Okay, now let's look at session 7.1. You have the 7.1 worksheet I gave you last time? Yes. So today we talk about 7.1, and then next week we're going to talk about 7.2 and 7.3. I strongly recommend you after class, go to the library and print out the worksheet 7.2 and 7.3. Okay, everybody? Because I gave you 7.2. Okay, then you just need to print out 7.3. Okay. Yeah, because this is our schedule. So even though I put 7.3 on Friday, but sometimes maybe we finish 7.2 in the middle of the class. Then we'll start the new session. Okay? So I hope you can print out like the whole week before that week. Okay. And let's see, 7.1. Okay, so all these their review. We usually use capital F to denote antiderivative, and then a small f is like the derivative of the antiderivative. Okay. And we already reviewed the derivative and antiderivative rules. So now let's go straight to examples. Okay, example 1. Find all the antiderivatives for f of x. So the antiderivative, it has the notation. Oops, let me see. Get here. Okay, so I can draw. Okay, I can draw now. So the notation, you have the integral, the sum sign, and you have f of x, the integrand, and you also have dx. So the notation has 3 parts: the sum, the s, and then the function, and then the dx. Okay, don't miss any of them because sometimes students forget about the dx. Don't forget about it. So dx is like our baby. Don't forget your baby in the mall. It's very important. So this is integral 5 e to the 7x minus 8x squared plus 7. What is square root of x? X to the what power? Yeah, 1/2. Very good. So because when we differentiate or integrate, we want to express any power function to x to the power. So we know what's the exponent. Okay. So we want to integrate the function f. Can we integrate this part? Yes. But this is a fraction. Do we have quotient rule for integral? Yes. Yeah, yes? Okay, look at this again. Do we have quotient rule or other rule for integral? No. So we need to simplify. So we get a sum or difference. So let's do that. Okay, this is integral 5 e to the 7x minus, okay, we want to simplify. So we have 8x squared over 9x to the 4th. We want to simplify. We want to split them. Okay, so we have this over that. Oh, next one. It's going to be plus or minus. When we split them, the next term is going to be plus or minus.
Plus.
Plus?
Yeah.
Minus. Yeah, the minus is like you distribute. Yeah. Oh, we don't differentiate yet. We simplify. Yeah. Because we don't have quotient rule. The antiderivative of a quotient is not equal to quotient of antiderivative. So we cannot integrate the numerator and then divide it by the integral of the denominator. No such rule. So we have to simplify. So we have a sum or difference. Then we can use the antiderivative formula. Yeah, we simplify it. So we get minus 7 x to the 1/2 over 9x to the 4. Oh, okay. That's the attendance alarm. Yes, so I will take the attendance after 10 minutes of the class starts because sometimes students might arrive late. Okay, if I tell your name, please tell me your favorite food. Okay, my favorite food is steaks. Sarah. Oh, Blaine. Steak. Mackenzie. Oh, so you can go to the restaurant together. Morgan. Oh, Bethany. Pizza. Also, my daughter's favorite food is William. Oh, I haven't tried that. Gabby. Oh, Patrick. Sushi. Oh, my dad was a sushi cook. He worked in Chicago for more than 10 years. So sometimes he brings sushi for me. Paige. Ah, great. Everybody is here. Awesome. Okay, so let's continue. We simplify it, right? So we have 5e to the 7x minus. So when you simplify, you group the coefficients together. And then you combine the x power, right? So the coefficient is a over 9. How about the x power? Remember, if you have, okay, let me write down the rule here. So if you have x to the a over x to the b, that's x to the a minus b, exactly. X to the a times x to the b is x to the a plus b, good. X to the a to the b is x to the, yeah, a times b, good. You still remember, wonderful. So x squared over x to the 4th is x to the 2 minus 4. Yeah, x to the 2 minus 4 is negative 2. Everybody? Okay. How about the next term? What's the coefficient? The numbers in front, negative 7 over 9. Oh, but how many x? So this is x to the 1/2 minus 4. Yeah. So what is 4? What over 2? 4 is what over 2? 8 over 2. So 1/2 minus 8 over 2 is, yeah, negative 7 over 2 dx. Right. So we simplify them. We don't have quotient rule, but we can simplify. Do you see we have a somewhat difference here? Now we can integrate term by term using those formulas. Okay. Everybody ready to integrate? So, according to the rule, when you have constant multiple, we just leave the constant multiple in front, right? So, like here, when we integrate 5e to the 7x, the 5 stays here, right? And integral of e to the 7x is 1 over 7. Yeah, 1 over 7 times e to the 7x. Good. Constant multiple stays here, and then integral e to the 7x. Like the a is 7. So 1 over 7 e to the 7x. Everybody okay with that? Okay, next part. So next part, constant multiple. 8 over 9 stays here. And then x to the minus 2 is, which one? The power function, right? Power function, we use this formula. Oh, well, you gotta be very careful. You use this formula when the power is not minus 1. Yeah, because when your power is minus 1, do you use this formula? No. We use the natural law formula. Okay, we gotta be careful. But negative 2 is okay, right? We can use that one. So integral x to the negative 2 is you add 1 to the exponents, then it becomes what? -1. Yeah, -2 at 1 is -1. And then what do? Divided by the new exponents. The new exponent is -1. Yes, that's the second term. Keep going. The third term, constant multiple, stays here. Okay, this is power function. When you add 1 to the power, what do you get? Good, -5/2. And then you divide it by the new exponent, which is, yeah, -5/2. And then don't forget plus C. You put plus C at the end. This is like your cell phone. You bring your cell phone always, right?
Why is it not 6/2?
6. Oh, okay. So -7/2 plus 1 is -7/2, but your common denominator is 2. So it's like 2/2. Yeah, that's why it changed to 5. Yeah, good. All right, so now let's simplify. So this is 5/7 e to the 7x. And then you see minus, they cancel, it becomes plus. 8/9 x to the -1. By the way, I prefer x to the -1, so you don't have to put the x downstairs. I actually prefer like x to the power because sometimes some problems you integrate one time, but some problems you may need to integrate twice. So it's better to keep it as the standard form. So then when you need to integrate second time, you can just look at this way. Okay. Yeah, like you learn about physics. Given the acceleration, you integrate one time, you get the velocity, and you integrate the second time, you get displacement. So sometimes you need to integrate twice. Okay, and then next one. Oh, do you see minus and minus cancel, become positive? And do you know when you divided a number, it's the same as multiply by its reciprocal? What's the reciprocal of that? 2/5. Well, 7 times 2 is 14. Oh, let me put it here. So it's like this guy times 2/5, right? The minus cancel. So 2 times 7 is 14. 9 times 5? 45. And you have x to the -5/2 plus c. That's the answer. We simplify the coefficient. And this is what we get. So any questions about example 1? All good? Okay. Yes. All right, let's continue. So now we need to integrate f of x dx. Okay. How about you try this problem? Everybody try this problem. Use the formula. Formula. Do we use?
We use.
Yes. Mm-hmm. What do we use? Let's see. The first term, e to the negative 10x. Which formula do we use? Which one? The exponential function. And we have e to the negative 10x. The a is like negative 10, right? So that's why we have 1 over negative 10 e to the negative 10x. Oh, sorry. I should copy the function down there before it integrates. Let me copy the function f here. So e to the minus 10x plus 4 over x dx. So the first term, we use the integral of the exponential function. So it's e to the minus 10 over negative 10. Everybody okay with that? Okay, the second term. Which formula do we use? Do we use the power one or the LM one? The LM one, right? So the integral of 1 over x is natural log of absolute value of x. But we have a 4 here. But 4 is like constant multiple. Just stay there, right? Just keep it there. And then the integral of 1 over x is ln, absolute value of x. And then plus c. So that's the answer. Be careful after you integrate. Don't put the integral sign anymore. Because if you put the integral sign, it means you're going to integrate one more time. Do you want to integrate one more time? No, right. So after you integrate, don't put the s and the dx after you integrate. Okay? So, yes, this is the 4 formula. Make sure you be familiar with them. Okay. That is example 2. Okay, let's continue. Example 3. Find f. If I know the derivative is this, and we know f of 0 is 1. So notation. An equation containing derivative. In this case, we have derivative of f is a function g, okay? So we call this is a differential equation. So an equation containing derivatives is called differential equation. And then the information f of 0 equals 1 is called an initial condition. So, after you integrate, usually you get a family of antiderivatives. Then how do you know which function is our f? Okay, we have a family of functions, but which one is the correct f? That's why the initial condition can help us to figure out c. So you plug in. Okay, you plug in and you plug in x is 0 and you plug in f of x to be 1, then you can find the c. Yeah. Okay, and then a differential equation coupled with an initial condition is called an initial value problem. So this is the initial value problem. Okay, let's try to solve that. Okay, so we have f of x is the integral of the derivative. So the derivative is 5 e to the 2x minus 4. Okay, we have a square root. So let's change this to the standard form. What do I mean by standard form? I want to have something times x to the n. This is the standard form. Okay? So, what is this? What power is this? 3 over 2. Yes, right, everybody? 3 over 2, no, 1 over 3, right? Yes, 3 over 2. Good. and then plus 7 dx. So we have 3 terms that we want to integrate. Okay, look at the first one. Which formula do we use? 1, 2, 3, 4. Which one? The 2 exponential function, right, everybody? So it's the same thing, but we divided by the coefficient of x in the exponent. So here, what do you get? What's the integral of 5e to the 2x? Do we multiply by 2? Or?
It's 1 over 2.
It's 1 over 2. So 5 constant multiple stays here. And integral. When we take the derivative, we multiply by 2. But then when we integrate, we divide it by 2. Okay, okay, that's the first term. How about the second term? What do we do with the minus 4? So minus 4 stays here. Then, okay, be careful. We are using the power rule. But the power rule, you see, we divide it by the new exponents. We don't divide it by the old exponents. Okay, so you calculate the exponent first. So let's see. This is our exponent, 3 over 2. When you integrate, what do you do to the exponent? Do you add 1 or you subtract 1? Add 1. So what is 3 over 2 at 1? 5/2, yes. So our new exponent is 5/2. Then you divide it by what? 5/2. Yes. Always calculate the exponent first. Then you put it downstairs. Okay. Don't put 3 over 2. It's not 3 over 2. It's the new exponent. Good. Okay, how about 7? What's the integral of 7? 7x. Right, everybody? So when you integrate a constant term, you increase the power by 1. So you get linear term, right? So we have x over there. And once you finish, plus c. Let's simplify the exponent, the coefficients. We have 5 over 2 e to the 2x. Okay, what is 4 over 5/2? You divide it by a fraction is the same as multiply by the reciprocal. What's the reciprocal?
A5.
Yeah, a5. So minus a5. And then x to the 5/2 plus 7x, and then plus c. So this is f of x. Everybody? And because of plus c, this is a family of functions. So which one is our f? Well, that's why we need the initial condition. So we plug in f of 0 is 1. So we plug in x is 0. And we plug in f of 0. So f of 0 becomes 1. So 1 on your left-hand side, that's f of 0. On your right-hand side, you plug in x is 0. So 5 over 2. Okay, so 5 over 2 times e to the x is 0. So 2 times 0. Minus a over 5. Do you know 0 to the whatever power is 0? Yeah, everybody? 0 to the whatever power is 0. Yeah. So this is 0 and plus 7. Yes?
0 to the power of what?
Oh, 0 to the whatever power. Okay, I need to be careful. So 0 to the k, as long as k is not 0, we get 0. But 0 to the 0 is defined to be 1. Yes. So 0 squared is 0, 0 to the 5 half is 0, 0 to the whatever power, as long as the power is not 0, then it is 0. Yeah. Just whatever power you like multiply 0 times 0 times 0.
Yeah.
Or you take the square root or the cube root of 0 is 0. But 0 to the 0 is defined to be 1. Yeah. Okay. Good. Yeah, very good. Plus C. All right. Exponential function. What is e to the 0? Yeah, very good. Exponential function looks like this. E to the 0 is 1. Okay. I need my charger. Okay. All right. Let's see. All right. Okay, good. Because I teach here, I teach applied track from 9 to 9:50. So then teach our class because it's 2 hours. So sometimes my laptop ran out of battery. Okay, so that is 1. This is 1. So we get 5 over 2. And then do you see this is 0, this is 0? Mm-hmm. So these two are 0. Ah. How do we solve for C? Subtract 5 over 2. So C is, what is 1 minus 5 over 2? Yeah, very good. C is negative 3 over 2. Good. So finally, our function. Copy down. So we copy this down here. 5 over 2 e to the 2x minus 8 over 5 x to the 5 over 2 plus 7x. Now my c is negative 3 over 2. So this is our final answer. Okay. That's the final answer. So sometimes if we are given initial conditions, we can plug in and find the c. All right. Now you do example 4. Okay. So you have the second derivative. You integrate one time to get the first derivative, and then you integrate the second time to get the function. It's like 2-step process. Integrate the first time, and see what you get, and integrate the second. and then divided by 2. So
Okay.
your new exponent is 2 here. All right, let's check our answers. Okay, so I'm gonna ask you to answer my questions one by one. Okay, so in my class, I like everybody to follow. So just imagine our class is like a family. So we're all like brother, sister. Maybe I'm your mom. Okay, so I'll ask you like to answer my question one by one. And how about start with Patrick, right?
Yes.
Okay, we want to integrate this second derivative. So we want to integrate 12x squared plus 6x minus 4 dx. What's the integral of the first term?
So we're gonna bring the 2 down.
Do we bring the 2 down?
Move 1/2.
Okay. Which formula do we use?
We use the second one.
The second one or the first one? X squared. X squared. Power function. Well, yeah. So power function.
Okay.
We look at the first one.
Okay.
So x squared, the integral
It'll be
becomes
plus 1.
+1, which is
So it'd be 3.
x cubed over the new exponent is what? So x cubed over.
Yeah. So it'd be 12x to the third cubed over.
The new exponent is
M plus. So 3 plus.
oh no, n is 2, so we have x squared,
Okay.
right?
So
That's why the square, the 2 plus 1 is 3.
it'll be over 3.
Yeah, it'll be over 3. Yes, very good. Okay, next, what's the integral of 6x? Yeah, 6 times x squared over 2. And what's your name again? Bethany. Okay, good. Let's see. Blaine. What's the integral of -4? What's the integral of -4? Yes. And after we finish, we have plus c. Right, everybody? Okay, let's simplify. What is 12 over 3? 4x cubed. Is 6 over 2? 3x squared and minus 4x plus c. So this is the first derivative. Is everybody okay with this step? Okay, then the function is the integral of the first derivative. So 4x cubed plus 3x squared minus 4x plus c dx. Okay, what is the integral of 4x cubed? What's your name? Sarah. What's the integral of 4x cubed? Yeah, very good. And next, what's your name? Morgan. What's the integral of 3x squared? Yes. Mackenzie, what's the integral of -4x? Yeah, x squared over 2. Everybody get used to the pattern. We increase the power by 1 and then divide it by the new exponents. And, how about the plus c? Gabby. Yes, cx. And then plus d. Very good. We have a new constant. We call it constant d. Okay, can we simplify? The 4 and 4 cancel, right? So we have x to the 4th, 3 cancel, plus x cubed. And what is 4 divided by 2? That is 2x squared plus cx plus d. So this is f of x. You see we have two unknown constants, c and d. And that's why we have two initial conditions. I mean, this is initial condition, but this is not initial. Because initial usually means t, limit the x is 0. Okay? We call this boundary condition. So you have the information of the two endpoints, and when x is 0 and when x is 1. So we call this boundary condition. Okay, so we can plug in. So when we plug in f of 0 is 4, we get the left-hand side is 4. Oh, if we plug in x is 0, what happens? It's 0. 0, 0, 0. Oh, how nice. We get this 0 and plus d. Yeah? Oh, we get the d is 4. How nice. But be careful. All these are 0 because they are power functions. We get 0. But if you have exponential function, remember when you plug in 0, e to the 0 is what? It's 1. It's not 0. So sometimes students would think, oh, f of 0 is 4. My d is always 4. Not always. It's true when you have power function. But if you have exponential function, that's not true. Okay, because e to the 0 is not 0, it's 1. Okay, how about we plug in f of 1 equals 1. So f of 1 is 1. My left-hand side is 1. Okay, we plug in x is 1. What's 1 to the 4th? 1. 1 cube? 1. Minus 2 times 1 square? Yeah. Plus c times 1 is c, right? And what is my d? Yeah, very good. Oh, do you see the 1 and 1 and 2 cancel? How do you solve for c? Yeah, minus 4. So c equals negative 3. Yes. Finally, my function. So copy down x to the 4th plus x cubed minus 2x squared. What is c again? Negative 3x. And d is 4. Yes. So this is our final answer. Okay. Yes. Oh, okay. That's a really, really good question. So here, you have f of 0 is 4, and f of 1 is 1. So both of the conditions is about f. So that's why you have to get to the f, then you plug in the f. But sometimes maybe the problem give you f of 0 is 4, f prime of 0 equals negative 3. If you get something like that, you plug in f of 0 is 4 in the f, then this is f prime. So you plug this in your f prime. So in this case, you plug in this here and then find the c to continue to get to the f, and then you plug in your f of 0 equals to 4 to find the d. Yeah, that's very good. Yeah. Okay. So this f because okay, if you have this part, you have F prime, then you know for sure this information will help us to find the C. Okay, and then this information about the F, it will help us to find the D because you already know the C. But if we don't have this, we have those two. You imagine when you integrate, you're gonna have Cx plus D in the F. So you need both information to help us to find both unknown. So C and D. Okay. Yeah, in general, if you have one constant, like the previous problem, you only have one constant, C, then they give you one information to find the constant. But in this problem, you have two unknown constants. So you need two information to find the constant.
So you move the F prime will interact with the F prime.
Yes,
Zero.
it depends
F prime
on the
zero.
initial condition. If
Yeah.
they give you F prime, you plug in F prime. If they give you F, you have to get the F.
Yeah.
Then plug in the F.
So what made you decide that F0 equals 4 wasn't C?
Yeah.
Because if we use that to find C, then C would be 4. Would that still be right?
Yeah.
Because there's nothing distinguishing.
Is it F of 0 is always going to be the last one?
Not always. That's why I say here, it's only true when you have power function. But if you have like e to the x, then this is not 0. Maybe this 1. Then your d is you move the 1 to the other side and find that. So I would say this is not always. So don't think of this is always give you d. This always give you c. Not always. Maybe I don't give you f of 0. Maybe I give you f of 2 and f of 4. So both give you two equations involving C and D. You get system of two equations. You can solve the two unknowns. So it's not always you can solve one constant within one equation. You might have a system of two equations. Then you solve C and D. Yeah, so not always. So just plug in and see what equations you get. If you're lucky, you can find the one constant within one equation. If you're not lucky, you get system of equations. Do you remember how to solve system of equations? Two methods, substitution method, and elimination method. Right. Okay, good. Okay, time's up. Have a good weekend. So don't forget to print out the worksheets. Oh, thank you. And do you need 7.2? I can print that out for you.
I can print it.
Oh, okay. So are you able to see the recording? So